class hours. So we have studied the dry bulb temperature that we can easily measure by any temperature measuring device. We have studied the dew point temperature. After that, we have studied the wet bulb temperature, and we have studied the wet bulb, two type of wet bulb temperature. One is psychometric wet bulb temperature, and another wet bulb temperature is thermodynamic wet bulb temperature. Thermodynamic wet bulb temperature is a true thermodynamic property, but this psychometric wet bulb temperature is not a true thermodynamic property, and we have seen the difference between them, and the difference is very less. So for all practical purpose, this psychometric wet bulb temperature is considered as a thermodynamic wet bulb temperature for all the analysis, because we can easily measure the wet bulb temperature using sling psychometer. Then we have also introduced about the relative humidity. We have studied the concept of relative humidity with examples. Then we have expressed the uh, enthalpy of moist air. We have derived the three equation to determine the property of moist air, and its unit is kilojoule per kg of dry air. After that, we have expressed the humid specific heat. This is also called the specific heat of moist air, and its unit is kilojoule per kg of dry air, Kelvin. The remaining property is the specific volume. So today we will introduce about the specific volume, and its unit is meter cube per kg of dry air. As we have already discussed, the all the property in psychometric is expressed in terms of per kg of dry air. So what is specific volume? So specific volume in psychometrics is different than the conventional definition of specific volume in other fields of science. In other field of science, specific volume is the volume divided by the total mass of all the components contained within the volume. So specific volume on in other subject like thermodynamics is the total volume divided by the total mass. Okay, but in psychometry, the specific volume is the volume divided by the mass of dry air component. So V psychometric is total volume divided by mass of dry air, and its unit is meter cube per kg of dry air. So now we will express the specific volume of moist air, specific volume of dry air, and specific volume of water vapor. They are exactly equal. Okay, so in Dalton's law model, each gas is conceived of as existing separately at temperature T and total volume V. So this is the mixture of dry air and water vapor at temperature T and P, and now we have separately fixed this dry air part in the same volume, similarly the water vapor part in the same volume. Then the pressure exerted will be the partial pressure of dry air, and pressure exerted is the partial pressure of water vapor, and total pressure will be the partial pressure of dry air plus partial pressure of water vapor. It is kept in mind that the volume is fixed for three cases. Okay, so this is the total volume. So we will divide the both volume by the mass flow rate of a mass of dry air. So this is the mass of dry air. Also here we divide the mass of dry air, so it becomes the specific volume of moist air, specific volume of dry air, specific volume of water vapor. Since the mass of dry air is constant in all the three cases, so specific volume is same for the moist air as well as for the dry air as well as for the water vapor. Okay, so this is about the specific volume, where specific volume of moist air is equal to specific volume of dry air is equal to specific volume of water vapor. Okay, next we will study the development of psychometric chart. So psychometric chart is the very important chart, because this chart is evaluate the property of moist air. So this chart is allowed in the examination. Without this we cannot solve the numerical problem, and psychometric chart is developed for a particular barometric pressure. As you can see in the figure, this chart is developed for a barometric pressure of 101.325 kilopascal. You can see in the psychometric chart, the x-axis is the dry bulb temperature, this x-axis is the dry bulb temperature, and y-axis is the humidity ratio, and its unit is kilogram of water vapor, kg of dry air. In some chart, in y-axis vapor pressure is also there, or sensible heat factor value is also given in the chart. Okay, so something happened wrong, so this is sensible heat factor. Okay, stop. Okay, now this is the the in some chart, vapor pressure is also given in the y-axis. So this is the vapor pressure. Now you can see the different lines in the psychometric chart. So we will discuss how these lines are constructed, so we can easily evaluate the enthalpy of moisture from this chart for a given state of moisture. Okay, then first question comes about this: why should we concern ourselves with the development of chart? This is question comes in mind. So answer lies in the following points. So first answer is that to develop chart for non-standard atmospheric condition. Okay, so for example, if you want to evaluate the property of moist air, it's similar. So in the Simla, the barometric pressure is lower than the 101.32 kilopascal. Here the Simla, the pressure is around 80 kilopascal. And if we evaluate the property of moist air from the sea level chart, then it will give the wrong result. So in order to develop the psychometric chart for non-standard atmospheric condition, we need to study the development of chart. So this is the first answer. And the second answer is that if we provide the properties in the table, then it will be very easy for us to read the property value from the table. Further, the data provided in the table are accurate and precise, even though we require to study of psychometric chart, because it simplifies the problems, it improves the understanding of air conditioning process. In research point of view also, this psychometric chart is important, because the reviewer asks to draw the psychometric process in psychometric chart, because it will improve our understanding about the air conditioning process. The third reason is that how different lines are constructed in the chart. So this improves our understanding about the behavior of property line related to other. If we know the development of psychometric chart, then we can easily relate the different property lines, how these lines are developed, so we can easily understand that. So these are the reason. Now we will study the property required to fix the state of moist air. So as you already know about this, the moist air requires three independent property to fix the thermodynamic state. Okay, because the moist air has a two component, dry air and water vapor. So according to Gibbs phase rule, F is equal to C minus P plus 2, where C is the number of components. So here number of component is 2, because it has dry part as well as water vapor part. So two component. Number of phase will be 1, because the we have only the gaseous phase, water vapor, and dry air is in gaseous phase, so phase will be 1. So the number of independent property required to fix the moist air is 3. So what are these three property? So first property is barometric pressure. Okay, so this pressure is the pressure exerted by the air column at a particular location. So first this property is required. After this, either we have to provide dry bulb temperature and RH, or dry bulb temperature and wet bulb temperature. Okay, so if total pressure, barometric pressure, that is fixed for a particular location, then only two properties are sufficient to fix the thermodynamic state, because this total pressure is equal to PdA plus PaWb, that is the partial pressure of dry air plus partial pressure of water vapor, provides an additional equation, additional relation, and reduces the property from 3 to 2, that is dBT and RH or dBT and WT. So for a given barometric pressure we require two independent property, either dBT and RH or dBT and WBT. Okay, now I will give the some information about the psychometric chart. So psychometric chart, the psychometric chart is based on the specified barometric pressure or elevation with respect to sea level. So every psychometric chart is based on a given barometric pressure of that location. Okay, the most common chart is based on 101.325 kilopascal barometric pressure, that is widely used, and we'll use this chart to solve the numerical problem. This is the normal barometric pressure at sea level at 15 degree Celsius. Next information about the chart is the sea level psychometric chart can be used without significant error for elevation between 400 meter above and below sea level. Okay, so suppose if you want to find the property of moist air at NIT Hamirpur, at NIT Hamirpur is approximate height from the sea level is 800 meter, and if we use the property of psychometric chart of sea level psychometric chart, that is based on 101.32 kilopascal, to find the property of moisture at NIT Hamirpur, then this will give the significant error. So we can use the psychometric chart up to 400 meter above or 400 meter below from the sea level. So this is the one point that I giving. The second information is about the ASRE publishes SI psychometric chart. So ASRE is the organization. We follow the rules and standard provided by the ASRE because it is universally accepted. So ASRE basically indicates American Society of Heating, Refrigeration, Air Conditioning Engineers. So according to ASRE, there are four types of chart they publish. First chart is the sea level chart, which is based on 101.325 kilopascal barometric pressure, and another chart which is available is above 750 meter height from the sea level, the pressure is around 92.6 kilopascal. We can say that location is approximately as in NIT Hamirpur because its height is about 800 meters. So if you want to find the property of moist air at NIT Hamirpur, then we need to use this chart, the second chart. Another chart available in the ASRE is plus 15 meter altitude. The barometric pressure is around 84.54 kilopascal. The location we can consider as a Shillong, which is the capital of Meghalaya. Okay. The another psychometric chart available in ASRE is plus 2250 meter altitude. The barometric pressure is around 77.04 kilopascal. We can consider this location is Simla, near about Simla. So from this chart we can evaluate the property of moisture of Simla. Okay, so after that we will start the construction of psychometric chart, how the different lines are constructed in psychometric chart. So the basis for the construction of psychometric chart lies on the phase diagram of the water, because the moist air has two part, dry air part and water vapor part. Because dry air is constant, so only variable part is the water vapor. Then we need to study the behavior of water vapor, and if you want to study the behavior of water vapor, then we have to focus on the phase diagram. So the we will start from the phase diagram of water vapor, and after that we will start the developing different lines of the psychometric chart. Okay, thank you.